Need to learn how to simplify or lower fractions? Then you're in the right place. Hi, this is Parker from Test Prep Champions teaching you how to pass the GED fast. And to do that, make sure you click subscribe down below. So in this video, I'm going to show you some awesome ways to simplify or lower fractions that are very simple, and we're going to get started right now. So the first trick is what I call the zeros trick. Okay, so this is the zeros trick, and this is really simple. Okay, so let me show you a few examples here because I think that's the best way to illustrate this. So imagine if we had an example problem like this, 30 over 50, and I told you to simplify this. Okay, so simplifying and lowering are really two words for the same thing. So whenever you've got a problem like this and you need to simplify or lower the fraction, I'm going to use those words interchangeably throughout the lesson. You can cancel an equal number of zeros from both the top and the bottom numbers in the fractions. So we have 30 over 50, so we can cancel out a zero from both of these. Okay, so this is a really simple way to lower fractions, okay, when you've got zeros. Okay, so let me show you another example here. So let's say we had something like this. We had 300 over 700. So how can we use the zeros trick to simplify this fraction? Well, we can cancel out an equal number of zeros here. So we see that we have 300 that has two zeros, 700, well, that has two zeros as well. We cancel them out and look just like that. Within seconds, we have simplified the fraction down to 3/7. So like I said, there has to be an equal number of zeros though. So let's say that you've got a case like this. Let's say that you have 5,000. So this time we don't have an equal number of zeros. Can we still use the zeros trick? Well, we can still use it. But remember, I said there have to be an equal number of zeros that you're canceling. So 300, that has two zeros. So we can only cancel two of the zeros in 5,000. So this still helps us simplify though. So that's going to leave us with 3 over 50. So still within seconds we were able to simplify this down. So let's look at one more example of this and then we'll move on to the next trick here. So let's say that we had 3,000 over, let's say, 40,000. So how would we use the zeros trick to simplify this? So go ahead, pause the video if you want, think about it, and then we'll go over this. Okay, so again, we want to cancel out an equal number of zeros. So we see that 3,000, well, that has three zeros, divided by 40,000, so that also has three zeros. So we can cancel out three zeros from the top number in the fraction, and also we can cancel out three zeros from the bottom number in the fraction. So what does that leave us with? It's going to leave us with 3 over 40. Alright, so that's an easy trick, and another trick is what I call the fives trick. Okay, so I'm just going to write 5 here, and I'm going to put it in quotes. So the fives trick for simplifying or lowering fractions, okay, so I'm going to call this the fives trick. So any number that ends with a 0 or a 5, you can divide both the top of the fraction and the bottom of the fraction by 5s. Okay, so let me show you an example. So this applies for numbers that end in 0 or 5. So let's say that we've got 25 and that's divided by 30. So how would you simplify this? Well, we see 25 that ends in a 5, 30 that ends in a 0. So if, again, numbers that end in 5 and 0, you can just divide them by 5. So let's divide 25 by 5. Let's divide 30 by 5. So 25 divided by 5 is just simply 5. 30 divided by 5 is 6. So we've just simplified this down to 5 over 6. Okay, so let's look at one more example of this. So let's say that we have 25 over 40. So again, let's say I gave you a fraction like this and I said, how would you simplify this? Well, you would see 25, that ends in a 5, 40, that ends in a 0, so we can just divide both the top number and the bottom number by 5, And so what does that give us here? Well, 25 divided by 5, again, is just 5. 40 divided by 5 gives us 8. Okay, so we don't have to do anything fancy here. We can just divide these by 5s. Okay, so now another trick is the even numbers trick. Okay, so let me write this out here. So this trick will work for even numbers. And so it's not the most time efficient or effective way to do it, but it will get you the right answer if you have to simplify or lower a fraction. Okay, so this is the even numbers trick. So this works for even numbers. So whenever you have even numbers, you can divide them both by 2 until you can't anymore. Alright, so let me show you what I mean by that. So let's say that you've got 6 over 12. Now, like I said, this isn't the most effective way to do this. This isn't the fastest way to do it, but this will always work for even numbers. So let's say that we have 6 over 12. Now you could divide both of these by 2. So what happens if we divide 6 by 2? That's going to give you 3. And what happens if we divide 12 by 2? So we do 6 divided by 2, which gives us 3. 12 divided by 2 gives us 6. We're now down to 3 over 6. Okay, and so we've got to reduce this even further because we can divide both the top and the bottom by 3. So 3 divided by 3 is 1. 6 divided by 3 is going to be 2, which gets us down to half. Which that's actually another trick which we're going to cover shortly in the video here, but the point here is that for even numbers, you can always divide them by 2. So we could also do it like this. Let's say you've got 10 over 14. How would you reduce this? Well, we see that there are 2 even numbers here, so we can always divide them both by 2. So what's 10 divided by 2? That's 5. What's 14 divided by 2? That gives us 7. So let's look at an example here where you have to do this multiple times. So let's say that I've given you something like this. So let's say that you have 16 divided by 20. Now you can also say, hey, these are 2 even numbers, so I can divide both of them by 2. So let's watch what happens. 16 divided by 2 is what? Well, 16 divided by 2 gives us 8. 20 divided by 2 gives us what? 20 divided by 2 is going to give us 10. So note that we had these 2 even numbers, 16 over 20, that we started with. We divided both by 2, but now we still have 2 more even numbers. We've got an 8 in the numerator of our fraction and a 10 in the denominator of our fraction. And if you're not sure what I mean by numerator and denominator, just know that the top number in the fraction is called the numerator, the bottom number is called the denominator. So we have 2 more even numbers, so we can again divide them both by 2. Okay, so what's 8 divided by 2? Gives us 4. What's 10 divided by 2? That's going to give us 5. So note here that we started with 16 over 20. We divided both by 2 and we got 8 over 10, so we had more even numbers. So we divided by 2 again until we couldn't do it anymore. And we couldn't do it anymore when we had 4/5. So with even numbers, you can always just keep dividing by 2 over and over again, okay, until you get down to the lowest form possible. Okay? Now, the other method here is just, it's not really a method, but it's just recognizing halves, okay? And we already kind of looked at this trick, but whenever you see a case where the top number is half of the bottom number in a fraction, you can immediately just simplify it to 1 over 2. So the fraction 1 over 2 is equal to half. So let's say that we've got a fraction like this. Let's say that I give you 5 over 10. So you could say, hey, well, there's a 5, and I see that 10 has a 0, so I could divide them both by 5. Or you could just, without even having to do 5 divided by 5, 10 divided by 5, you could just say, well, the top number in the fraction is half of the bottom number, so that is going to simplify to half. See how that works here? So here's another example of this. So we've got 25, let's say we've got 25 as our numerator, and we've got 50 down here as our denominator. So you might say to yourself, well, 25 that ends in 5, 50 that ends in 5, let me divide both by 5s. Okay, and you can do it that way. Or you can just say, hey, 25 that ends in 5, 50 that ends in, you could just say, well, 25, that's half of 50. So you don't even have to do any math. You just say, well, the top number is half of the bottom number, so you can just right away know that that's going to simplify to half. Now, like I said, you could also do it like this. You could divide both the top and the bottom by 5, and watch, it's just going to create a little bit of extra work for you, because 25 divided by 5 is 5. 50 divided by 5 gives us 10. So see how we divided by 5 here, okay, but it didn't give us the simplest fraction here. It didn't give us the most simple fraction here. We've got to do another step here. So if you divide 25 by 5 and 50 by 5, you get 5 over 10, and you're also going to have to do that again. So you're going to have to divide 5 by 5 and 10 by 5, which gets you half. And that's a perfectly valid way to do it. But if you just had seen 25 over 50 and recognized that 25 is half of 50, you don't need to do this middle step here. You can just say, well, 25 over 50, that's equal to half. All right, and that would be the end of it. Okay, so here's one more example of this. So we could have, let's say, 15 over 30. Okay, so again, you could say, well, you know what, 15 that ends in a 5, 30 that ends in a 0, and you could divide them both by 5. And that's a perfectly valid way to do it. Or you could just recognize right off the bat that 15 is half of 30, and just by recognizing that, you don't even have to do any math, because you know that it's going to simplify down to half, which is 1 over 2. So that's the halves trick. Okay, and so now let me talk about strategy here a little bit. Okay, and so for simplifying and lowering fractions, all right, so the strategy that is always going to work, but sometimes it can take a little bit longer, is to think about the biggest number that you can divide both the top and the bottom number of the fraction by evenly. Okay, so let's go back to an example. Let's say that you've got 16 divided by 20. So again, so you can look at this and you can think, well, 16 divided by 20, those are both even numbers, so I can just keep dividing by 2 until I can't do that anymore. Okay, or what you can also do is you can think, what's the biggest number that I can divide 16 by? And then I can also divide 20 by. That's going to give me a nice whole number rather than something with a decimal point and a bunch of digits that just go on and on and on, because we don't want that. Well, you can think it through. So can we divide 16 by 2? Can we divide 20 by 2? The answer is yes. Okay, what about 4? Can we divide 16 by 4? And the answer is yes. Can we divide 20 by 4? And the answer is yes. So what's that going to give us? That's going to give us 4, right? Because 16 divided by 4 gives us 4. 20 divided by 4 gives us 5. Okay, so let's look at another example of this. So this is kind of like using the strategic approach, which can require a little bit of guess and check type work here. All right, so we could do 20 over, let's say, 30. Okay, and so let's pretend that we're not doing the zeros trick here, because you know from the beginning of the video that the simplest way to do this would just be to clip off the zeros, but let's say that we weren't doing it that way just for the sake of an example. So we want to think about the biggest number that we can divide 20 and 30 by. Okay, so you just kind of have to guess and check. So what about 2? Can we divide 20 by 2? Yes. Can we divide 30 by 2? Yes. Okay, what about 3? Well, you can't divide 20 by 3, so 3 is not going to be the biggest. Okay, what about 4? Can you divide 20 by 4? Yes. Can you divide 30 by 4 evenly? No. Okay, what about 5? Well, yes, you can divide 20 by 5. You can divide 30 by 5. Okay, so 5 could work. Now, what about 6? So you can't divide 20 by 6 evenly, but you can divide 30 by 6 evenly. Okay, so on and so forth, and you would just kind of have to reason your way through this until you come up with 10 and realize, hey, I can divide 20 by 10 and I can divide 30 by 10. And what happens if you do that? Well, if you divide 20 by 10, you're going to be left with 2. And if you divide 30 by 10, you're going to be left with 3. Okay, so this strategy always works. You want to think about the biggest number that you can divide both the numerator and the denominator by to get a whole number, okay? So can you divide 20 by 10? Is that going to give you a whole number, or is that going to give you something strange like, 3.12, something that goes on and on and on, which isn't what we want to do? And the answer is yes, okay? But there's an even faster way to use this strategy, so you don't have to sit here and find the greatest common factor, because that's really what we're doing here. All right, when you're thinking, well, what number can I divide 20 by? What number can I divide 30 by? What you're essentially doing is you're trying to find the greatest common factor. So there's a shortcut there that we can use to do that. So when you see 20 over 30 here, okay, what you can do is you want to take the bottom number and subtract the top number. Okay, and this is an amazing hack if you understand how to use it, and it's really simple here. So you want to take the bottom number, or whatever number is biggest in your fraction. So in this case, 30 is biggest, and you divide it by 20. Or I'm sorry, you subtract by 20. So you do 30 minus 20, that's going to give you 10. So what does that tell you? Well, that tells you that your next step is going to be to try to divide both 20 and 30 by 10 and see if it'll go evenly. Meaning, what happens if you do 20 divided by 10? Well, 20 divided by 10 is going to give us 2. 30 divided by 10, what does that give us? That's going to give us 3. Okay, so see how all I did, rather than sitting here trying to reason my way through it and figuring out the greatest common factor, in other words, figuring out the biggest number that I can divide both 20 and 30 by evenly, I just subtracted the bottom number and the top number. Okay, so let's look at a few more examples here. So what about, let's say, we have 14 divided by 20. Okay, so again, these are both even numbers, so you could simplify this by dividing them both by 2 until you can't simplify them anymore, all right? Or you could also reason your way through it and think, what's the biggest number that I can divide 14 by, and then I can also divide 20 by. But the fastest way to do it, okay, rather than the greatest common factor method, okay, is to just do 20 minus 40. So you take the biggest number in the fraction, subtract by the smallest number. Or not 40, did I say 40? I meant 14. 20 minus 14, okay, so what does that give you? That gives you 6. Now, some of you, if you're following along right now and you're really thinking about this, you might think, you just got 6 here. You can't divide 14 by 6 evenly. You can't divide 20 by 6 evenly. All right, so you're right. So you want to do 20 minus 14 and see what number you get here. And then you want to think, can I divide 14 by 6 evenly? Can I divide 20 by 6 evenly? And the way you can test that out if you don't know your times tables and your divisions tables well off the top of your head, just use a calculator. Put 14 divided by 6 in your calculator. Okay, let me do that now. Let's see what we get if we do that. All right. So if you do 14 divided by 6 in the calculator, you get this. You get 2.333. You get a bunch of 3's that just keep repeating. All right. So that's not what we want, because when I say 14 divided by 6, okay, it doesn't divide evenly, okay, meaning you're going to get 2.3 and a bunch of 3's. We don't want that. We want a nice number, okay? We want a nice whole number like a 2 or a 3 or a 4 or something like that. We don't want something with a bunch of decimals, okay? So 6 isn't going to work. But we can break 6 up into its factors here, all right? So we can break 6 up into 2, and we can break 6 up into 3 here. And now we're going to test both of these. So what about 3? What happens when you do 14 divided by 3? Well, you're going to get a strange number like this. So, and again, you can do this in your calculator. You're going to get 4.66 and a bunch of 6's that keep repeating, all right? And that's not what we want. So what about if we divide both by 2? So 14 divided by 2 is going to give us 7. 20 divided by 2 is going to give us 10, and now you're in the simplest form here. Okay, and so would it be faster to just divide both 14 and 20 by 2 and see what happens? Yeah, that probably would have been faster, but that's how it goes with these fractions questions, all right? Sometimes you might use one strategy, like dividing both the top and the bottom by 5, for example, and maybe it would have been faster to just, use a different strategy, like maybe it would have been faster to just use the greatest common factor method or subtract the bottom by the top. You don't always know sometimes, but the point is here that sometimes you just got to jump in and just try things here. Okay, and so I'm showing you all these different strategies here, not because I want you to get confused and get tripped up, okay, because that's not going to work, all right? I don't want you to get confused and get tripped up here, all right? But what I do want you to do is I just want you to pick a strategy that you think is going to work and just try it until you get down to some kind of answer. All right, so let me give you something else here. Let's say that we've got 44 over 60. Okay, so how would you simplify this? What's the fastest way to simplify this? So probably the best way to do it, okay, and you could certainly divide both by 2. You could say, what's 44 divided by 2? What does that give you? That's going to give you 22. So what's 60 divided by 2? Well, 60 divided by 2 gives me 30. All right, so I've still got even numbers here, so I'm not quite in simplest form yet. So what if I do 22 divided by 2? What does that give me? That's going to give me 11. And what about 30 divided by 2? That's going to give me 15. Okay, and so now I'm down to simplest form. So that would be a perfectly valid way to approach this. But you could also do it the other way. So you could do it this way. So you could do 60 minus 40. So again, you want to take the bottom number, or the biggest number, okay, and subtract the smallest number. So we do 60 divided by 44. Or I'm sorry, not divided by, I keep saying divided by 60 minus 44, which what does that give us? That gives us 16. So now what's the next step? The next step is to divide 44 by 16 and 60 by 16 and see if they go evenly. So 44 divided by 16, what do I get? If I do 44 divided by 16 in my calculator, I'm going to get a weird number. I get 2.75. So I know that that's not the greatest common factor. It's not the 16. So what do I do? Well, I want to break 16 down. So what can I break 16 down into? Well, I could try 8, and I could break it down into 8 and 2, because 8 times 2 is 16. So let's try 8. So what happens if I do 44 divided by 8? I get 5.5, so that's not going to work. Okay, so I could also try 2, and again, I already showed you what happens if you try it with 2. Okay, but we could also say, well, what else can we do here? What about 4 times 4? Because 4 times 4, that's also going to give us 16. So we have 4 times 4 here, so we could also try dividing 44 by 4, and we could also do 60 divided by 4. All right, and what's that going to give us? What happens if we do 44 divided by 4? That's 11. And if we do 60 divided by 4, what does that give us? 60 divided by 4 gives us 15. Okay, so see what I mean here. So sometimes you've got to combine different strategies in certain cases. Sometimes you've just got to try a few different things. And the fastest way, if you've got 2 even numbers, sometimes you might think it's just to keep dividing by 2. Okay, or you might want to try something like this, where you take the 60 minus 44, you get 16, and then you break 16 up into factors, right? So 4 times 4 give you 16. You test, what happens if I divide 44 by 4? What happens if I divide 60 by 4? Or you might think, well, 16, I can divide that into 8 and 2. Okay, so what if I try 8? Doesn't work. What if I try 2? Well, 2 works, but it doesn't get me to the simplest form. I'm going to have that little intermediate step here. So let me think about something else. Let me try 4 and 4. Okay, so sometimes, again, like you might have to combine different strategies. Like we had that earlier example here before I showed you halves, right, where we had 6 over 12. So again, in this case, we have 6 over 12. Okay, so we say, hey, there's 2 even numbers here. So what do I do? Well, we can divide both the even numbers by 2. So remember we did that, and we got 3. So if we do 12 divided by 2, what does that give us? 6. Okay, so we're not in simplest form here. We've got 3 over 6. Okay, but we can't divide by 2 anymore, because 3 divided by 2, okay, that's going to give us a weird number, which is not what we want to do. So now you also would have to recognize that, you can do it two different ways. So you can do 6 minus 3, take the biggest number minus the smallest number, and you'll see that that's 3. And then you realize, well, hey, that gives me 3, so then you test it. What happens if you divide 3 by 3? If I divide 3 by 3, that gives me 1. Now, what if I divide 6 by 3? That's going to give me 2. That gives me half. Okay, so you could do it that way, but remember, all right, the fastest way to do it would have just been to recognize that 6 over 12 that is half. So you could have just said, well, 6 is half of 12, so the fraction is going to obviously simplify down to half. All right, so see what I mean? There's not like a formula like, plug this number in and you're going to always get this. You've just got to use different tricks here, okay? And so you just got to find different tricks and just practice simplifying some fractions until you try different strategies out until you start to figure out how to make it work here for you. But the example I wanted to illustrate here is that sometimes you'll have to combine different strategies, because if you do 6 over 12, you divide them both by 2, you get the fraction down to 3 over 6, okay? And so you might look at that and say, well, I can't divide by 2 anymore, so I'm done. And in this case, you're not done, because you would have to recognize that 3 over 6, okay, it's not yet in simplest form, all right? So you have to do 3 over 6. So you could just take the top number, divide it by the bottom number. You could think about it that way, like I showed you with that subtraction trick here, okay, where you take 6 minus 3 and you get 3. So in that case, you divide both the top and the bottom by 3. Now, I hate to spoil all the fun, but you can also simplify fractions using your calculator, which I'll show you how to do in a future video. But for now, your next step is to watch my video on fraction basics. So go do that now, boost your score on the GED. I wish you the best of luck.